Have another problem. Say let PQ be continuous as real valued function defined on -1 comma 1 and u1 is -1 to 1 to r and I is equals to 1 to be solution of the differential of the ordinary differential equation d2u by dx2 plus px du dx plus qxu equals to 0, x belongs to -1 comma 1. Right, satisfying u1 greater than equal to 0, u2 less than equal to 0, and u1 0 is equals to 0, u2 0 is equals to 0. Now let w be denote the Wronskian of u1 and u2 then u1 and u2 are linearly independent. B, u1 and u2 are linearly dependent, and C, wx is equals to 0 for all x belongs to -1 comma 1, and D, wx is non-zero for some x belongs to -1 comma 1. So that's all. PQ be the continuous real valued function defined on this u1 is equal to this without that is satisfying this, but the w Wronskian of p1, then u1 are linearly independent linearly dependent. wx is equals to 0 for satisfying this u1 u2 equals to 0. That means they have common 0, so wx equals to 0. That means they have common 0. Didn't define on u1 is equals to this, uy is close to close the satisfying ui is greater than u2 less than equal to 0. Let w didn't Wronskian of then the u are linearly independent. This will be true. Okay, so there is a problem. PQ be real valued function, continuous, be continuous. So w u1 u2 0 common 0, then w of 0 will be equals to a of u1 0 u2 0 u1 dash 0 u2 dash 0. So it is equals to 0, wx will be 0, so it is true, and this b and c will be true. Right, question number 14. So that's an easy question. Now we will come to the next problem, question number 15, which says that let p be a continuous function on R and W be the Wronskian of two linearly independent solution y1 and y2 of the ODE of the ordinary differential equation d2y dx2 plus 1 plus x squared dy dx plus pxy equals to 0, x belongs to R. So let w1 is equals to a, w2 is equals to b, and w3 is equals to wc. Then what is true? A less than 0 and b greater than 0, b A less than B less than C, or A greater than B greater than C, A by modulus of A is equals to B by norm of B is equal to C by norm of C, D 0 less than A less than B, and B greater than C greater than 0, right? So that's all. So which one is true? So they asked in 2000 and they have asked this question in 2015, right? So P be the continuous function of linearly independent solution of this. Now Px will be equals to 1 plus x square, and Q of x is equals to is continuous, right? That means P of x, and it is P of x. So what we have, it is continuous. Y1 and y2 are linearly independent. This implies W of x, y1 y2 is non-zero. Wx is non-zero in fact for all x. Now W1 is equals to Z1 W. So what we have, Wx is equals to A of e to the power minus integration A1 divided by A naught dx is equals to A of e to the power minus integration of 1 plus x square of dx, right? So what you can say here, from W of x, e to the power minus integration 1 plus x square dx, 1 plus x square 1x divided by this, log of W is equals to log of A plus log of e to the minus integration of 1 plus x square dx. So plus log of A, so plus minus of integration 1 plus x square of dx. So log of W of x is equals to log of A minus x cubed by 3, right? So if we have some W, then we will say W of 1 is equals to alpha. So W of 1 is equals to a relation between this, na? Itu asli pun orang then W of 1 is equal to A e to the power minus 1 by third is equals to A. That means A e to the power minus 4 by 3 is equals to A. And W of 2 is equals to B equal to A e to the power minus 2 minus 8 by 3. A e to the power minus 6, 8, that means 8 by 3. B is equals to this. W of 3 is equals to C. A e to the power minus 3 minus 27 by 3, that means 9, is equal to A e to the power minus 12. C is equal to A to the power minus 12. That means now this implies, okay, so this nice problem, right? Wx is if A greater than 0. If A greater than 0, e to the power minus x is a decreasing function. We can say this. Now if A greater than 0, then Wx is decreasing function. If A less than W is also A can never be 0, since and solution linear also we know that the given Wx is either or never 0. Wx cannot be positive at one point and negative at another. So consider W1 is cannot have the difference, and so also cannot hold together. then Wx is decreasing. Okay, so now e to the power minus x is decreasing, right? Decreasing. E to the power minus x, so to the power minus x cube by 3 also decreasing. Now what is important is to if so wx is also decreasing, right? Decreasing if a less than 0 and increasing if that means it is decreasing if a less than 0, I mean sorry, a greater than 0, because a greater than 0, then this is decreasing if a less than 0, and increasing if a less than 0, because f of x is decreasing minus f of x is increasing, right? So that's what we have used here. So from this we can say f of x is increasing, then minus f of x is decreasing. So we can say that Wronskian, that is wx is so what we have is a. So if a less than 0, then b must be less than 0 and c less than 0. This should be true. So option a less than 0 and b greater than 1, because as linearly wx is non-zero here, and either wx is greater than 0 or wx is less than 0 for all x, or less than 0. That means if it is greater than 0, then it should be greater than for all, so it is cannot be true. A less than a less than b, less than c, or a greater than b, this is false. Say a is equal to -1 and b is equal to 2, c is equal to 3, then again we have a contradiction, because either wx is greater than 0 or wx is less than 0. So this is again false, and this is true because modulus of that value must be equal. This implies that a and b and c have a, or that means they should have same sign. This is same as saying that they should have same sign. So this is true. 0 less than a, less than b, b greater than, okay, but and this true, right? So from here what we can say, okay, so this is also true. This may be possible because all are greater than 0. So we can say that option C and option D are possible conditions for here. So that's an important problem, because so B and C are correct, right? So okay, so that's an important, B cannot hold together. B a less than B and B greater than C cannot be by option B. Okay, so okay, W, so